Chupa Chups isn't just a lollipop, it's a global legend. Every day, the factory produces over 12 million lollipops, which are exported to 150 countries. And it all began in 1958 with a simple idea: adding a stick. From meticulously testing ingredients to the iconic logo designed by Salvador Dalí, Chupa Chups knows how to make an impression. Ready to see how the taste of childhood is created? Let's dive in. The Chupa Chups company was founded in 1958 by Spanish entrepreneur Enrique Bernat. He introduced the concept of a lollipop on a stick, making it easier for kids to enjoy candy without getting their hands sticky. Enrique came from a family of confectioners. Before creating Chupa Chups, he worked for a company that produced traditional candies. At some point, he realized that regular candies posed a challenge for children. They often got their hands dirty or spent too much time unwrapping and handling the candy. His idea was to create a treat that could be enjoyed without touching it directly. The solution came quickly: attach a wooden stick to the candy. This innovation made the process of eating candy both simple and hygienic. Originally, the lollipop on a stick was called gol, from the Spanish word for goal, hinting at the idea that the lollipop resembled a ball, and the mouth was like a goalpost. It wasn't until the 1960s that the brand adopted its modern name. The word chupa comes from the Spanish verb chupar, meaning to lick, highlighting how the product is consumed. The simple slogan, Chupa un chups, which translates to lick a chups, was straightforward yet catchy in my opinion. The main ingredients of a Chupa Chups lollipop include sugar, glucose syrup, acids, citric or malic, flavorings, and natural or synthetic colorings. Quality control starts with the raw materials. The company only works with suppliers who hold certifications that meet international standards. Before establishing a partnership, they inspect the production, transportation, and storage processes. This involves factory and warehouse inspections. Inspectors evaluate the appearance, color, smell, and texture of the ingredients. For instance, they check for lumps in the sugar, any off odors in the syrups, and whether the colorants meet specified standards. I find this level of meticulous attention to detail truly impressive. Next come the physical and chemical tests, such as measuring the moisture content of the sugar, checking the acidity of citric or malic acid, and analyzing the glucose concentration in syrups. Naturally, microbiological testing is also conducted. This involves checking for harmful microorganisms, such as bacteria, mold, and yeast, that could compromise product safety. Additionally, the ingredients are tested for the presence of heavy metals, like lead and mercury, pesticide residues, or other harmful substances. Once the ingredients pass inspection, they are stored in specialized warehouses. Storage conditions are strictly controlled. Temperature and humidity levels are tailored to the specific requirements of each type of raw material. Regular monitoring ensures that the ingredients remain in optimal condition, preventing spoilage before they are used in production. The next step involves transforming solid sugar crystals and viscous syrup into a uniform, pliable mass from which the lollipops will be shaped. This requires reducing the water content in the mixture and blending the main ingredients, sugar, glucose syrup, and water, in precise proportions to achieve the desired texture and flavor. The process is carried out in specialized equipment, vacuum kettles, or melting tanks. These machines have double walls for even heating and are equipped with stirrers to prevent the mixture from burning. Temperature and humidity sensors inside the equipment ensure accurate heating, while automatic dispensers precisely measure and mix the ingredients. In a kettle that stands about twice the height of an average person, sugar and water are combined in a ratio of approximately 3:1. Once the sugar dissolves, glucose syrup is added to achieve the optimal texture. The mixture is then heated to around 230 to 250 degrees Fahrenheit. At this temperature, the sugar dissolves fully and the water begins to evaporate. When the mixture reaches approximately 284 degrees Fahrenheit, the process of inversion begins. Some of the sucrose breaks down into glucose and fructose due to the high temperature and the addition of acid. The temperature is then gradually increased to 300 degrees to evaporate most of the remaining water. The consistency thickens, and the sugar dissolves completely. The mass is stretched using specialized machines to enhance its transparency and give it a glossy finish. In some cases, a small amount of air is incorporated into the mixture, creating a softer texture and ensuring even color distribution. I was absolutely mesmerized watching the caramel stretching process. As a kid, I would have gladly traded all my toys for a week just to witness that spectacle. Once the main batch of sugar and syrup is ready, flavorings like strawberry, orange, or others are added, along with natural colorings derived from plants and fruits or artificial ones. Citric acid or malic acid is also mixed in to create a tangy taste. If the candy is designed with layers or a mosaic pattern, different colored and flavored batches are combined during the stretching process. For example, the rainbow Chupa Chups are made using a layering technique. It's an incredible process. I'd go back to the factory just to watch it all over again. The threads of caramel are semi-transparent, stretching into beautiful, colorful bundles. I've mentioned this before, but see it for yourself, and you'll understand my excitement. The process of forming lollipops at the Chupa Chups factory is highly advanced and almost entirely automated. Human operators are responsible for monitoring and adjusting the equipment, as well as performing quality checks. But overall, machines handle the heavy lifting. A large sheet of sugar mass is fed into a machine for portioning. There, it is either cut or pinched into small pieces. Each piece is precisely measured to match the exact weight of a single lollipop, typically around 5 to 10 grams. These portions then pass through a mold press, which gives the lollipops their desired shape, whether round, oval, or something else. The molds are cooled to help the candy harden quickly. One of the most crucial steps in the production process is inserting the stick, a key element that made the brand so iconic. This step is also fully automated, with machines ensuring both accuracy and efficiency. Plastic or wooden sticks are automatically fed onto a conveyor, where they are cleaned and inspected for quality. Each stick must be straight, sturdy, and free of defects. The candy mass is then either molded directly around the stick, or the stick is inserted into the center of the still malleable mass. A machine inserts the stick with precise calculations of angle and depth to ensure it is securely fixed in place. Once inserted, the lollipop cools quickly in its mold, creating a strong bond between the stick and the candy. The quality control during this stage includes a visual inspection of shape and size. Machines equipped with artificial intelligence scan the lollipops for defects such as incorrect size, uneven color, or missing sticks. Even the stick's attachment strength is tested. Specialized testers check whether the stick is firmly secured. Each lollipop is also automatically weighed. If the weight falls outside the acceptable range, the lollipop is rejected. After being shaped, the lollipops are transported via conveyor to cooling chambers or cooling conveyors. The temperature is lowered gradually to prevent the candy mass from cracking. Only after this process do the lollipops achieve their final hardness and become ready for packaging. During the final quality check, a specialized tasting panel evaluates whether the lollipops meet expectations. They assess if the flavor is as intended, whether the flavorings are evenly distributed, if the color matches the standard samples, and even check the product's transparency. This part of the tour is usually my favorite, but this time, watching the caramel stretching process took the top spot. Yes, I'd say it 3 more times if I could. I don't know about you, but if someone had told me as a kid that such a job existed, I would have been over the moon. Just imagine, every day you get to taste test your favorite candy. What could possibly be better? Of course, it's not as easy as it sounds. It requires specialized training and a long journey to land that specific role. But if I'd known about it as a child, nothing would have stopped me. Every batch of product comes with its own unique identification number, which allows the origin of each ingredient to be traced. If any issues are discovered during testing or reported by consumers, a thorough investigation is conducted to identify the source, such as a specific raw material supplier. Each Chupa Chups lollipop is wrapped in a special wrapper, a fully automated process to prevent any contact with human hands. Once wrapped, the lollipops are sorted and packed into larger boxes or tubes for transportation to stores. The finished products are then sent to warehouses, where they are distributed to retailers and distributors. Fun fact: the iconic Chupa Chups logo was designed by the famous artist Salvador Dalí. He created the bright design featuring yellow and red floral shapes resembling a daisy, and he cleverly placed the logo on the top of the wrapper to ensure it was always visible. This logo has become legendary and remains a key element of the brand to this day. Pepperoni, cheese, or veggie? What kind of pizza would you pick? While you're dropping your choices in the comments, I'm choosing to head over to a massive frozen pizza factory. Did you know that over 2 billion frozen pizzas are sold worldwide every year? The United States leads in consumption, with the average American eating around 50 pounds of pizza each year. The process starts with mixing the ingredients for the dough. Large industrial mixers are used, which automatically add the precise amounts of flour, water, yeast, salt, sugar, and vegetable oil. The flour is stored in huge silos or containers, from which it flows through special pipes into the mixers. A sensor system carefully measures the exact amount of flour needed for each batch of dough. Water, oil, and other liquid ingredients come through dedicated pipelines, and each mixer is equipped with dispensers that automatically add the required amounts of these liquids. For smaller dry ingredients like yeast, salt, and sugar, separate dispensing systems are used to accurately measure and add them to the mixer at just the right time. Operators simply monitor the machinery and ensure proper dosing, while the entire ingredient delivery process is fully automated. The dough is mixed until it reaches a smooth, uniform texture, a process that usually takes about 10 to 15 minutes. After mixing, the dough is left to rest for a few minutes, allowing the yeast to activate so it becomes soft and elastic. After mixing, the large mass of dough moves down the line, where special automatic tongs or portioning blades separate equal pieces from the main batch. The machine is calibrated to a specific weight, ensuring each dough piece is the same size for consistent pizza quality. Each piece is then sent to the shaping station, where it's laid out on a conveyor belt or platform. Next, a machine with presses or rollers carefully but evenly flattens each dough piece to the required thickness. Modern production lines use sensors to monitor the diameter and thickness of each pizza base. If a piece is not flattened uniformly, the press machine automatically corrects it or sends it back for another shaping cycle. To create a nice edge, machines gently lift the dough's edges using special mechanical attachments or air jets that lightly blow around the perimeter, kind of like the iconic dress scene with Marilyn Monroe. This technique helps form a border that keeps the toppings from spilling out during baking. The finished pizza bases go through a final check as they move along the conveyor belt. Sensors inspect the shape and evenness, and only then are the bases sent to a light pre-baking step to set their shape. Through this process, between 3,000 and 5,000 pizza bases are formed every hour. That means the factory can produce up to 120,000 bases in a single day. The prepared pizza bases move along the conveyor into an industrial oven. The oven temperature is preset, typically ranging between 662 and 752 degrees Fahrenheit. The conveyor moves at a steady pace, ensuring each base bakes evenly. This high temperature allows for quick baking, about 1 to 2 minutes, depending on the thickness and size of each base. These ovens usually feature multiple heating elements placed above and below the dough to ensure even heat distribution. This setup creates a crispy crust that remains soft on the inside. During baking, the oven slightly humidifies the base surface with specialized steam nozzles, which help the dough stay tender within. After baking, each base passes through a series of sensors that check its color, texture, and thickness. If a base is under or overbaked, it's automatically removed from the line. The hot bases come out of the oven and are immediately moved onto a cooling conveyor. This cooling step is essential to stop any further baking. Cooling is managed by special fans that quickly lower the base's temperature before the next stage. While the pizza base is baking, a separate line is preparing the sauce. Tomatoes, spices, salt, sugar, and sometimes oil or other ingredients like basil or garlic are mixed together. The sauce is cooked in large vats where it's continuously stirred to achieve a smooth, uniform consistency. After cooking, the sauce is cooled down so it doesn't interfere with the following stages when it will be spread onto the dough. The par-baked pizza base travels along the conveyor to a saucing machine. This machine spreads the sauce evenly across the surface of the dough. To avoid overloading, a small border is usually left sauce-free, creating a clean edge on the pizza. The machine precisely measures the amount of sauce for consistency, so each pizza turns out identical. Interestingly, the manufacturer recently began reducing the amount of preservatives used in their frozen pizzas. After the sauce, the base moves further along the line to the station where other toppings are added. This step can be fully automated, although in some factories, workers are involved in the process. Toppings like cheese, pepperoni, mushrooms, vegetables, and olives are dispensed onto the pizzas using automated dispensers or specialized containers. Cheese is usually added first and in the largest amount to create a stretchy layer when baked. To ensure even distribution, special sifters or mechanisms gently sprinkle the toppings over each pizza. Vegetables, meats, and other components are added in precise proportions, so each pizza has a consistent flavor and appearance. After the toppings are added, the pizza moves on to a crucial step, flash freezing. It goes into a tunnel freezer where the temperature is kept extremely low, reaching -86 degrees Fahrenheit or even lower, just so you know. At this temperature, the pizza freezes within minutes. Flash freezing is important because it preserves the dough's structure, the texture of the cheese, and other ingredients, which helps maintain the product's original flavor. After freezing, the pizza bases, or fully assembled pizzas, move down a conveyor belt to the packaging line. Machines automatically position them correctly to avoid any wrinkling or deformation. The pizzas are typically wrapped in clear plastic film to prevent moisture loss and preserve freshness. This film is applied automatically, and special thermal elements quickly seal it along the edges, creating an airtight package. For certain types of frozen pizzas, vacuum sealing or an inert gas environment, such as nitrogen, is used to keep the product fresh for longer. In these cases, a machine either removes the air from the packaging or adds gas to prevent bacterial growth and oxidation. Once wrapped in plastic, the pizzas are automatically transferred to a machine that places them in cardboard boxes. This cardboard is usually sturdy to protect the pizza from damage during transportation. The machine folds the boxes around the pizzas and securely seals them with adhesive tape or special clips. Next, each box is labeled with product information, such as the name, ingredients, expiration date, and cooking instructions. This stage is also fully automated. A machine scans barcodes and prints labels according to the type of pizza. After labeling, each box goes through a quality control system. Sensors and cameras check for intact packaging, clear labeling, and the absence of any defects. If a box doesn't meet standards, it's automatically removed from the line. Following quality control, the pizza boxes are grouped into cases or stacked onto pallets. Robotic arms can automatically stack the boxes to save space during transportation. Before shipping, the pizzas are temporarily stored in large freezer rooms, which maintain a stable temperature until they are loaded into refrigerated trucks for transport to stores. And here's where you'll see something unexpected.